Hello, welcome to the Athens series game. So it's available online. If you have a computer, you can access it. You need a recent web browser, such as Chrome or Safari or Firefox, and it's also advised to use a mouse. So you click on the Athens series game. There are other series games developed in the context of nextgen, but the Athens one is the one we're looking at today. You click on it, and then you are redirected to a welcome screen. So this is our virtual neighborhood. This is the main interface of the game. So it's made out of components which are all connected to each other. The virtual neighborhood contains around 7,000 inhabitants. It pumps water from far away, the water supply to the top left. This is this blue box, and the water is redirected to 3 groups of households, which represent all the houses in your neighborhood. Neighborhood A and B will use water, and their wastewater is redirected directly to the primary wastewater treatment plant, which is this big brown box at the bottom. In the case of neighborhood C, the wastewater is connected to a sewer mining unit. Now, the sewer mining unit is the central point of this particular case study. It is reusing the sludge which comes from the wastewater and the water, and it is then connected to a tree nursery. The sewer mining unit allows the production of fertilizer and also allows heat reuse. It also allows, by producing fertilizer when it reuses some of the tree prunings, some savings, because we don't have to dispose of the tree waste as they are reused to make compost locally. The sewer mining unit also directs some partially treated water to the aquifer, and the aquifer is used to pump water to water the trees in your sewer mining unit. So that's roughly all the important components. Now there are indicators which are visible on screen. First of all, there is the big circular economy score on top. The goal of the game is to just maximize that score. So you will be able to change some components and the technologies and the households, or how many sewer mining units you have and all that, and then hopefully your circular economy score should go up depending on what decisions you take. The water demand met indicator, the center top here, is when you click on it, there's a bit more detail, is basically an indication of how much of your water demand you manage to meet. We calculate it by looking at the amount of water demand there is, and if it's greatly exceeding the baseline of what you usually supply, that's not a good sign. We also look at the aquifer stress. So the aquifer depends on rainfall, but also the water that comes from the sewer mining unit. So if it's empty, then you're stressed at 100%. We look at indicators of energy saving at the very bottom. So if I click on it, you have an idea of the energy footprint in your virtual neighborhood. So for example, you'll notice that the households, as far as water is concerned, all the households make something like 97% of your energy expenditure, maybe when they use the shower or whenever they use water, basically. The main water treatment plant only represents, for the treatment of the wastewater, only represent 1% of your energy footprint. There's another 1.6% which is used to pump the water from your external supply far away, 400 kilometers away to Athens. And then you've got a small amount of energy used by the sewer mining. We only use 1 unit at the moment, and it represents 0.16%. We also estimated the cost of wastewater treatment per year, and that's it for the energy saving wastewater part. Note that when we look at the other indicators, which are centered around the tree nursery and sewer mining, we have some interesting things going on. So we have at the moment, you've got an interface in which you can change population, rainfall, the types of technology that you have in the neighborhood, but also the amount of sewer mining units. We have only one sewer mining unit active, which is plugged to neighborhood C, which only has 10% of the household. So there's a limited amount of sludge that comes to the sewer mining unit, and therefore it's not able at the moment to do much heat reuse, and it's not able to produce much fertilizer or to save much on land pruning, on land saving for everything that's branches that you don't have to normally put to waste disposal. So if I increase the number of sewer mining units to 50, which is a huge number, then you notice that if I click on it, you manage to do some heat reuse up to 10%. So this is the amount of energy you can save by reusing heat. You manage to not produce any significant amount of fertilizer, at least no amount that is surplus. So you make fertilizer, but this fertilizer is immediately reused by the tree nursery. So you don't make enough to export fertilizer or to have a surplus. And as far as landfill saving is concerned, so you're reusing some of your branches, and you save around 11,000 euros of pruning cost, and that's 1% of your waste disposal. So yes, this is the situation presently. Now, what happens if, we have put 50 sewer mining units, but it's a lot. Basically, you have reached a cap of what you can do at around 6. If I displace that to 6 sewer mining units, you see the results are the same. So, with 10% of the household, we have 7,000 people. 10% of the household represent around 700 people. The wastewater that's produced can be handled by 6 sewer mining units, and we have reached the maximum that we can improve. Note that we have a marginal gain in our circular economy score. We improved from 25 something to 25.85%, so it's a marginal gain. And similarly, our water demand is 86%, what we managed to meet, and initially it was, if I go back to 1, it was 84%. So we managed to save on 2%, and we can meet the water demand a little bit better. Now, what if I connected the other neighborhoods, A, B, and C? So I maximize the amount of, say, sewer mining units, and I connect neighborhood A, so we'll have more sludge, and neighborhood B, so we have even more sludge. If I do that, then you save still around 2% of your water demand. Your aquifer stress shuts down. It was 100%, now it's 0%. Your aquifer is full because it's alimented by a lot of water coming from sewer mining unit. And then your heat reuse is 100%, so you save a lot of energy. Your fertilizer production, you have a surplus production of 1,200 tons. And you save around 12% of your pruning waste disposal. So, what else is happening? Well, you realize overall some energy saving, and your circular economy score has shot up to 31%. So that's quite significant. Note that we use 50 units, and that's basically the maximum you can treat and use for something of the size of 7,000 households. Now, what else can we do to improve our circular economy score? Well, we can probably add extra things, like for in each household, what would happen if we use water reuse or efficient water use technology. For example, what if I replace a conventional shower head in each house in the neighborhood A with a fog shower, one of these NASA special fog shower heads that mix air and water, then consume less water. So if I click on that, then you notice that your water demand goes from 86% to 96%. So we save a lot more by implementing that on the household level, and we also have a lot of energy saving, going from 9% to 22%. So it looks like overall there are combinations of technologies to use with sewer mining, but also at the level of the household. If I, for example, use rainwater harvesting in every single household, we will also save on the water demand and other aspects of the circular economy. So you can explore all sorts of devices, the type of toilet, the types of sink, and so on, and you can connect them to different sewer mining units, and you can overall see how the circular economy in your neighborhood is improved. Thank you very much for listening. I hope this was interesting. Thank you. Bye.